Hi, I'm Ranveer Uppal. For the final project for this course, I chose to implement the curve tracking algorithm in MATLAB and Simulink. The challenge was to develop a curve tracking control law for a mobile robot such that it is able to follow any arbitrary curve in the XY plane. Essentially, the robot should be able to do two things. Assuming it starts in a point that is not located on the curve, it should be able to find the curve and converge to it. After having found the curve, it should then be able to accurately follow it till the end. My control algorithm is based on the lateral Stanley controller developed by a team at Stanford. This implementation has been customized for the differential drive model of a mobile robot. Since the goal is curve tracking, I have assumed a constant forward velocity and implemented a controller only for the steering input. The controller developed can be understood with the help of this diagram, which is a visual representation of the geometry of curve tracking using a differential drive robot model. The algorithm focuses on minimizing two terms: the cross-track error, which is the distance between the robot and the closest point on the curve, and the heading error, which is the difference between the direction of the curve and the current heading of the robot. This is why the steering input control at any point is calculated using this equation, which has two terms. The first term essentially steers the robot towards the curve using a gain KE and the cross-track error. When the cross-track error is very large, the first term will tend towards a value of pi by 2 and force the robot to sharply turn towards the closest point on the curve. The second term ensures that the robot follows the curve by forcing the robot's heading to match the direction of the curve at the point. In order to turn towards the curve, we need to know whether the curve is on the right side or the left side of the robot. To do this, we define a term gamma, such that the value of gamma is positive when the curve is on the left and negative when the curve is on the right. This is a screenshot of the implementation of the algorithm on Simulink. It has three main components: the trajectory generator, which is implemented as a MATLAB function, the controller, which is also implemented as a MATLAB function, and the differential drive model, which is a Simulink block.